The video of NVIDIA's game developer talk at GTC regarding neural rendering has finally been released publicly, and I was definitely right on this so that I could find out, do we have any additional information about DLSS 5, which is being described by NVIDIA as a type of neural rendering. But also, I had been really interested in how does DLSS 5 relate to other things we'd heard described as neural rendering in the past, like neural texture compression, neural materials, things like that. And then we've also seen other things described as neural rendering in situations where you see some companies working on, can you basically have an entire game, all of the 3D stuff, basically just generated by the AI in real time, that type of thing. So there's a lot of different things that can be called neural rendering, but they're all seeming quite different. And so I think it's important to separate out what those are. And I was also hoping we'd get some additional information about how these interact with each other out of this talk. So I have now watched this. Keep in mind, I am a math teacher and part-time tech YouTuber. I am not a game developer. So I'll be describing this as best as I can. I do have the transcript up here, which is the transcript of this video. And to be clear, that this is a talk given to an audience of game developers describing these technologies, so it is pretty technical in nature, but the source will be linked in the video description. Now, one thing that I really was hoping to get out of this was a lot more information about DLSS 5. However, what we got was a little bit limited. Honestly, out of this 38-minute video, they spent only a few seconds talking about DLSS 5. Here's what they said. So they say that neural techniques show up across the graphics world in several different patterns, and they're not mutually exclusive. You might do your rendering in the traditional, straightforward way with meshes and lighting and shading, etc., using your traditional pipeline, and then use machine learning on the result in order to provide a quality or style uplift. In the keynote on Monday, Jensen showed DLSS 5, which is an example of this type of neural rendering. So that's pretty much all we got about DLSS 5 in a 38-minute talk from NVIDIA about neural rendering. So the idea is basically just acknowledging that DLSS 5 isn't really interacting or changing the traditional rendering pipeline used for the games up until the very final output. So it's just taking the output of the final frame. We've heard from NVIDIA clarifying that it takes the basically the final 2D color output data from a frame plus motion vectors, and then it applies what they're describing here as a quality or style uplift. Now, that's very different than what we had seen with previous NVIDIA talks on neural rendering, which is what they describe here as neural rendering being used in the pipeline. So basically they're saying, how does this interact with your rendering pipeline, right? DLSS 5 happens at the very end of the process and is applied to basically the final output of your traditional rendering process is the input into DLSS 5. Now what they're saying is you could use machine learning inside your rendering pipeline. So this case is your pipeline is still there and still mostly the shape that you're used to, but your neural networks will run inside of it, evaluating materials, decoding textures, and computing shading results. And then they'll show some, they describe some of that in more detail for a good chunk of the rest of this talk. So in other words, this is describing more of what I think most people thought of as neural rendering before the introduction of DLSS 5. So basically, this version inside the pipeline that they're describing here is trying to do things that game engines already do, like represent textures and compress them, or take really advanced combinations of stuff to create very realistic looking textures with very realistic lighting interactions. So the thing is that to do that, traditionally, you take certain inputs, like a whole bunch of layered texture information, etc., and then you run like lighting simulations using very specific hand-coded math, like BRDFs. And with textures, you have some form of compression that you can do, right? And there's ways that these are done. But generally, to get more complicated and more advanced, you have to have more complicated, more advanced math. So the idea of using neural techniques inside the rendering pipeline is really about, could we do that using different inputs, and then the process for getting the output that you see involves machine learning. So remember that machine learning, as far as like what it's actually doing, is matrix algebra. And so you input vectors with some type of input information, and then it runs through a matrix that has a whole bunch of weighted parameters that were trained by taking these inputs, trying to get a good output, and then basically guessing and checking through a whole big training process until it learns how to give very accurate outputs given those inputs. Now, there's a performance cost to running that matrix to infer what's supposed to happen from those inputs. Just like there's a performance cost when you're doing more traditional math in your rendering pipeline. So in this case of using neural techniques to basically do what games already do, you're looking at what are the pros and cons in terms of things like how much memory space is taken up with the traditional algorithm versus the neural algorithm, the neural technique, and as well as the performance time it takes. How many milliseconds of time does a GPU take to compute that process? And then also, what is the quality of the output that you're getting? So, in other words, this is just looking at trying to do things that games do, but do it in a different way, and then look at the pros and cons of doing that. Now, then the third option for neural rendering is basically entirely generative, and that is kind of a different case than what we're seeing with either DLSS 5 or with just doing certain elements of the rendering pipeline through neural techniques instead of traditional ones. So they're saying that this generative one is taking basically, instead of a traditional pipeline at all, you have very limited or reduced pipeline, and a neural network is responsible for generating some or all of the frame. And they're saying that all of these techniques, none are more or less neural. They're all a part of neural rendering, and that they describe up above that these are not mutually exclusive, meaning you could use them in combination with one another. So I think that it's true that you can view all of these as neural rendering, but I think it's important to remember how different all of these are, right? And what do they mean about them not being mutually exclusive, right? So you could replace elements of your traditional rendering pipeline with neural techniques, and then you could apply a DLSS 5 style process to the final output at the end of that rendering chain. Or I guess you could do a generative approach where there's very little information traditionally rendered, and then AI just decides what to do with all of it. And then I guess you might also apply some kind of a process to that final output image, like a DLSS 5 process at the end of it. So that, I think that's what they mean about these not being necessarily mutually exclusive. But while they're not mutually exclusive, it is very clear that they are very, very different techniques. And so I think that's where there's a lot of this controversy coming out, I think with DLSS 5, is I think a lot of people initially thought, when we talk about neural rendering, we're talking about things like this, where you're changing elements of the traditional rendering pipeline rather than kind of a post-process on the final output frame. Because when you're doing that within the traditional rendering pipeline, they are describing this as basically a deterministic, like the developers can can get the exact output that they're looking for. So like with neural texture compression, you basically figure out a latent texture. So textures are encoded as latent feature maps stored as multi-channel neural data instead of traditional texels. Each texel holds a learned feature vector representing material information rather than final colors. And a neural decoder reconstructs the full resolution texture at runtime. So this enables high compression levels, but it can have, I think, a bit more of a compute cost than the traditional texture rendering. But in the end, you're just kind of still getting what the game developer wants, and they can try this out in their game development process. Now, this has some interesting, demos given. So they showed the difference between using a BCN texture compression, which I'm not a game developer. My understanding is that is a pretty standard texture compression technique. And they're showing that this image, now this video unfortunately is only 1080p, so it's not like super high quality assets, because even if your image is only 1080p, if you upload at 1080p, YouTube kind of kills the bitrate a bit, but whatever. Anyway. So I wouldn't make too much out of what we're actually seeing here, but they're claiming that this Tuscan Villa scene with BCN textures takes 6.5 gigabytes of VRAM. However, if they then do the same thing using neural texture compression, they can get it down to 970 megabytes. So basically a gigabyte. So they go from a little over 6 gigabytes of VRAM to a little bit less than 1 gigabyte of VRAM. Now, my understanding here, though, is that the trade-off is that the neural technique, I think, is probably a little bit more costly in terms of milliseconds of rendering time to do that decompression. Or in other words, rather than doing a more traditional decompression, you're taking kind of a different sort of data as your input vector, and then it's outputting this image through, a different technique. I think that technique is a little bit slower compute-wise than a more traditional method of doing it. And that's where, they're talking about kind of the pros and cons of this. So the idea here is that the advantage to neural texture compression is better compression. So you could have smaller game install sizes, smaller game downloads, less footprint on your VRAM when running the game, that kind of thing, but potentially at a cost to the actual runtime rendering if running that decompression on the neural texture took longer. Now, they're also mentioning that, well, you could think of this as taking the same quality, roughly, at a smaller memory footprint. They're talking here, I think, about, or if you run it at a equivalent like memory amount, you can get more detail out of the neural version compared to the BCN, I think is what they're trying to say here when rendering using the same amount of VRAM. So that's what we're looking at here. So you can see that there could potentially be some advantages to this, and there are ways that game developers can play around with the SDK for neural texture compression. They also talk about the neural materials, things like that, although it sounds like the neural texture compression seems a little bit more ready to go. Their description of the neural materials is more that it's kind of an area of active research for NVIDIA still. This one seems maybe a little bit more work still to be done, etc. Anyway, but the idea is kind of, again, that traditionally doing an advanced material, you do a whole bunch of layers where you're thinking about like the underlying ceramic, you're thinking about the like the gold plating, and then you're thinking about the glazing on top of that, then dust in the environment, and you get 19 different texture channels to actually get this material going. But then their neural technique stores it as latent code, and then you do a training algorithm, and the training algorithm does take a lot of work, but that training algorithm is in training. It's not happening during the actual render of the game in the game engine. So that's the idea on this. So then when you're actually running the code, it's not quite as crazy. And this, doing their neural version of the materials, is down to 8 texture channels rather than 19 texture channels to get a pretty high quality result here, similar to what they were getting. And they're showing that there could be some actual performance benefits to this, looking at the neural inference version of this versus the reference, and that they could compute it in fewer milliseconds because they're getting it down to the, like I said, getting it down to 8 instead of 19. Anyway, so that seems to be the idea behind these rendering pipelines. Now, one thing I'll say is it felt like we had seen a lot of these before, so maybe there'd been a little bit more work on that. So I'm actually wondering if, in other words, I was kind of surprised with DLSS 5 because DLSS 5, as we can see, is very different from this, right? This was really working on things that game engines traditionally do, right? And then working on doing that through neural techniques and seeing what the pros and cons are of that. Whereas this is kind of skipping over all of that, jumping to the final output frame. Seems like a very different idea, right? So I'm wondering, were these just developed simultaneously, or are they feeling like, are they hitting a wall here? Is it not actually that useful in real time? I don't know. That's actually something I'd like to know more about. I do expect us to start seeing a lot more experimentation with this type of thing. And we've seen AMD in partnership with both Sony and Microsoft talking about like PlayStation 6 and next generation Project Helix, Xbox console / maybe PC-ish sort of thing, talking about using neural techniques and neural rendering. I'm curious whether they're thinking more along the lines of neural techniques within the pipeline or more of a post-process on the output rendered frame. Now, the final version of this, where almost everything is generative, is really a very different thing. NVIDIA's discussion of that here didn't really focus around games. They were talking about it more in terms of if you want to do training for like autonomous vehicles and you want to take in video footage, you have video footage, but that you can't interact with that in 3D. So instead, they talk about, well, what if you took that, two-dimensional camera data from a few different viewpoints and then used some techniques to generate a three-dimensional output. And they talk about using Gaussian particle fields in order to do that. But the problem is, as you get towards the edges of those techniques, even though you can get a fully 3D environment, which is kind of interesting out of a two-dimensional video, that the further you get out of places where you had data, you start to get these just kind of splattery looking lack of detail. So now they're talking about taking that splattery looking lack of detail on the edges of the scene and then using a generative AI to output a 3D model of that at the edges of the scene and getting a lot more detail out of that. So that's their discussion here. But again, this didn't really seem to be like for use in real-time video games. They were talking, like I said, more about this car data. And then also talking about how you could take the cars that you're only seeing from one angle and run a generative AI on it to figure out what a fully 3D render of that car would look like, and then insert it into the scene. And then they show off like how you get this 3D scene and they can spin the cars around, which obviously you wouldn't do in real training information or anything like that, but that they're able to do that. So this is certainly interesting, but like I said, they're not currently showing that off as like a rendering technique. However, I think we can see how long-term something like this could be applied to game rendering, where could a game essentially just have like really, really low quality outlines of a description of what they want to be here. Like basically just, there's a tree here. That's basically just some code that represents tree. And then a generative AI creates a photorealistic tree there. Now, if we get to that level of generative AI applied to game rendering, that's where I think there's a lot more questions about, is everybody going to see a different thing? How deterministic is it? Like, at what level can game developers try to prompt that to have control over the artistic intent? So I think we need to be clear about what all of these things are, right? Because I think some people think that that's what DLSS 5 is, and that's certainly not what DLSS 5 is. It's not giving it just some blob saying tree and letting the generative AI completely decide what the tree is. DLSS 5 is trying its best to adhere to what the game developers did get out of a traditional render, but then it is allowing the AI to kind of decide how to enhance that. And at least at this point, it's questionable how much control the developer has to tweak that output. And then there's always, everybody has ethical concerns over, generative AI use, etc. There's all those kinds of questions. I think the less controversial one is more using neural techniques within the pipeline in a deterministic way, where you always, get the same thing out that goes in, and it's just kind of looking at the pros and cons compared to a more traditional rendering technique as part of the pipeline, just kind of increasing the tools that are available. So I think from if you were going to rank these in how controversial they are, this would, I think, be most controversial, second most controversial, least controversial. But then, we really have to see how all of this goes, because at this point, we haven't seen a lot of this in actual games yet. So I'm curious what all of this will look like in the future. But this stuff is definitely research that is happening, and I think we will be seeing more and more of it. And like I said, I'm just trying to follow this stuff, understand it as best as I can, and try to bring that information to you guys as well to continue the discussion and all of that. So that's what we got from NVIDIA regarding neural rendering at their GTC talk. Like I said, not a whole lot of talk about DLSS 5 in this. It was seemed to be a lot more focused on the pipeline versions for games, and then they did talk quite a bit about this, but it wasn't really as a gaming use case, at least at this time. Let me know what you guys think about neural rendering techniques, the different types, all of that. The source will be in the video description, and I hope all of you have an excellent day.